Today we are going to start the second chapter of class 10th ICSE, and the name of the chapter is chemical bonding. Here already I have written few things like chemical bond, types of chemical bonding, all these things already I have written. So I will explain you one by one what is a chemical bond, what are the various types of chemical bond which we can form, and what are the conditions, and what are the various compounds which we see in our day-to-day life. Some of them are ionic, some of them are covalent, some of them are coordinate compounds. Why we call them like that? So today we are going to discuss all this, but not in this one video. I will have 2-3 videos based on this chapter. So today I'm just going to give you the brief of this chapter. I'm just going to start with the basic introduction of a chemical bond. So what is a chemical bond? Friends, let me tell you that when two atoms come together, when two atoms combine, they have to be remain close to each other, and that force of attraction which hold them together is known as a chemical bond. So that is a chemical bond. Basically, it's a force that holds two atoms in a molecule together. Now, chemical bond can be of three different types. One is the ionic bond, the second one is the covalent bond, and the third one is the coordinate bond. Now, what are the basic, if I say what is the basic difference between ionic and covalent bond, that will be the most important, you can say, parameter to start with. So let me start with the ionic bond first. Ionic bond, it's a bond, it's a force of attraction which hold a cation and anion together. Now you will say what is a cation and what is an anion and what is the ionic bond. So let me give you a definition which I hope you can read in your book also. Ionic bond is a force of attraction, or shall I say ionic bond is formed by loss and gain of electron. Means one atom will lose electron and the other atom will gain electron. So the atom which will lose electron, basically that will be metal and that will form a cation. You can see here already I mentioned Na positive, and the atom which will gain electron will form an ion. Like they can be non-metal like Cl negative chloride ion, already have shown you. So when a metal atom will lose electron and a non-metal atom will gain electron, they will come together, they will attracted by each other because they have opposite charge, and this force of attraction, which is known as electrostatic force of attraction, is known as ionic bond. So basically ionic bond is an electrostatic force of attraction which is present between a cation and a anion. So example is Na positive Cl negative, and together they will form NaCl, and all of us know what is NaCl. It is sodium chloride, it is common salt, table salt, we know this thing. Now why Na positive and Cl negative are coming together? Why can't I have ionic bond everywhere? So basically that's a very important question to address here, that why every element is not able to form ionic bond. There are some elements which can form ionic bond, some compounds are ionic, but many other compounds are not ionic, they are covalent, which I will come to later. So why some ionic compounds are there but there are some covalent compounds? So let me start with that. Ionic compounds, ionic compounds are formed between metals and non-metal. This is very important. If you just focus here, metals have low value of IP. IP means ionization potential. Ionization potential means ionization energy, which already I have taught you in the class. Again I am going to repeat that. Ionization energy is the amount of energy, it is the amount of energy that must be given to an atom so that electron can come out of it. So that an electron can come out of it. So this kind of a energy which we have to give to a metal atom so that it can take out the electron is known as ionization energy. So low the value of IP, ionization potential, more easy electron will come out from the metal. And boys, if you just remember from the periodic table, that on the left hand side of the periodic table we have all these metals like sodium, potassium, calcium. Because they are on the left hand side, they have a large atomic size, so they have very low value of ionization potential. That's why they can lose electron very easily, and once they will lose electron, they will form cation which is Na positive. They will form cation which is Na positive. Then at the same time, we have a non-metal. In case of a non-metal, the if you just focus here, high EA, high EA, non-metal should have high value of electron affinity. Again, you are familiar with this term, electron affinity. Those who just want to have a quick revision, let me tell you, electron affinity is the amount of energy released or given when we add an electron to a neutral atom. So when we add an electron to a neutral atom, energy can be given out, or maybe we have to give the energy to fit that electron into that atom. And that energy is known as electron affinity. So those non-metals like fluorine, chlorine, which have high value of electron affinity, when they come in contact with metals which have low value of IP, they form ionic bond. So if I recap, or if I say in a nutshell, metals with low value of ionization potential make ionic bond with known metals which have high value of electron affinity. And if you see, these known metals are on the right hand side of the periodic table and metals are on the left hand side of the periodic table. So the gap between them is very large, or shall I say they have a large electronegativity difference. They have large electronegativity difference. Friends, sometimes, shall I say this thing, they do ask you this question in your board exam, that what are the conditions which are required for the formation of ionic bond. So then you have to answer that there should be a large electronegative difference between the metal and the non-metal. Metal should have low value of IP, that is ionization potential or ionization energy, and non-metal should have high value of electron affinity. Electron affinity is also known as electron gain enthalpy, if you recall that. Okay, so when they come to